UPPTCL has been pioneering from the very beginning in development of the high-end technologies and the high voltage grid systems, and in many cases UPPTCL stands first in respect of the development of the system. Others have learned, and of course, as CEA, because I belongs to the fraternity of CEA, Central Electricity Authority, whose responsibility is the overall long-term planning of the system, design and construction standards and safety regulations. We also learn lot many things from the able field engineers and the policy makers of such a large state. Next item is electromechanical components like transformers, circuit breakers, and other things, and of course the towers and conductors. Though these seems to be simple, but lot of technical development are taking place with the time in these also. Insofar as they are here in this particular phase, they are robust, well designed, well protected, and the OEMs have provided their best of the designs to the power utilities so that they run long. So it's our duty to maintain them properly, and in the field of maintenance, we can apply what is also known as the modernization. So one component of the modernization is that the better O&M practices, enhancing the capacity of the existing assets by way of better cooling, by way of higher size conductors, by way of better supports or the modified supports. But more important is the condition monitoring and the real-time data analysis using the artificial intelligence techniques and other things. So condition monitoring give the predictive analysis, and we can have the timely maintenance activities and the distribution companies, the a role. To maintain the power quality issues and mitigating the harmonics. So there all we need the power electronics. have the subsea cable. Subsea cable again is not manufactured in India, but for the subsea cable also, the process has been started by Government of India. I am also one of the member of that. Digital substations have to come across ISTS and major state networks. We need integrated control centers operating with AI-assisted decision making, seamless renewable integration with real-time forecasting, a strong and stable pan-India green energy corridor, which will have a mix of HVAC, HVDC, and the renewable energy management centers. Your renewable energy management centers have to be part of the transmission grid, without which the large-scale integration of the renewable is not possible. Similarly, to absorb the load, we have to have a modernized distribution sector also. And in the distribution sector also, the concept of distribution system operator should come on. Otherwise, it will be difficult to manage multiple injections of the system at various points which are in small quantities. So concept of the aggregator has to come, and distribution system operator and aggregators will combinedly function and will give necessary fee to the state load dispatch center to run and control the system. India can become a global leader in the cross-border electricity trades. Interconnections are proposed between India, Saudi Arabia, other Gulf countries like Oman, India, Sri Lanka, and from the mainland to the islands. So these are the wish lists and these are the proposals. So we have to be part of this transformation, and this transformation should be based on innovation, which could result in resilient infrastructure, which could serve the purpose of sustainability, and overall, it will be an act of the nation building, in which the electricity infrastructure will play a major role. So, dear friends and dignitaries, this I specifically mentioned that what is going on at the national level and at the international level. So this is the scenario. Now, when we come to this, these my structured topics. This is structured topic that why the modernization of transmission system. Are the existing system not modern? To a large extent, I would say they are modern. When they were built, they were the best. But with the passage of the time and emergence of the technology, what is happening, the new things are coming. So we have to embrace the new technologies by way of accommodating them, and they should well fit into our system, whatever we have. So the basic need is power demands are increasing, generation is at far off places, and when that generation is at far off places, bulk amount of power is to be transferred over long distances. Here the long distance is the key. Long distance AC transmission has its own problem. So we have to resort to the high voltage, and that too plus minus 800 kV or plus minus 525 kV or plus minus 320 kV HVDC link wherever feasible. Renewable integration demands a flexible and a modern grid. Grid has to be modular. It should have the capacity of augmentation. Suppose two transformers are there in the system now, so another transformer could be placed. So it should have at least that much of the space, and higher capacity transformers should be get accommodated without much hindrances. For that, what happens? The planning and design stage is very important. Sometimes the approach road or the carrying of the transformer, heavy transformers is very difficult. So we have to design our layout, keeping in view that some new systems may come. And when large parts of the renewable energy are being developed, we do not know how much will come well in advance. In the existing species, whatsoever are left, the other type of the generation and the higher amount of generation may come. And here it is heartening to note that earlier used to be only the solar or the wind. Now is the era of hybrid generation. That is the solar, wind, and also the energy storage facilities. If we have on paper the concept of the, you can say the energy storage or battery energy storage, but we have to think in advance, or the planner at his table, at his desk, at his desktop has to see where the plan would be there and how much capacity of the say battery energy storage system or other type of the systems could be placed. Sometimes we have to put the reactors in between also, not from the very beginning. So reactor bay has to be there. And also sometimes what happens, the crossing over of the different voltage lines are involved. 400 to 400 kV crossing, 400 to 765 or 400 to 220 kV. These crossings have to have sufficient margins. So why I'm emphasizing in these margins? Because a lot of problem comes when the railway crossing and the highway crossings takes place. So these are particularly requirement, and also particular requirement is when you change the route of the line or you change the alignment of the line for the crossings, you have to necessarily again take the PTCC clearances. So those PTCC clearances, of course, not visible in the physical system, but they are to be obtained and are statutory requirements. Case in example is, say, somewhere in Chhattisgarh, I should not name the exact place, the induction effect coming because of the multiplicity of the lines crossing each other. And it was typical layout, and you can say everybody is under pressure to speedily complete the line and system. So maybe something got missing, but remedial actions are being taken, and remedial actions are possible, but not without taking the shutdowns. So our aim here is not to avail lot of shutdowns, avail only the minimum of the shutdowns possible, and keep our system intact and keep it operating in a better way.
हेलो, आप सभी से अनुरोध है कि आज बैठ जाइए। आज की वर्कशॉप में देश के चुनिंदा एक्सपर्ट्स को बुलाया गया है और ये कोई यहाँ पर कोई मनोरंजन का कार्यक्रम नहीं है। ये एक सीरियस वर्कशॉप है जो टेक्निकल सब्जेक्ट के बारे में है। ठीक है, तो कोई यहाँ पर कोई स्टेज पे मनोरंजन नहीं होने वाला है कि साहब बड़ा मनोरंजन होगा तो आपका ध्यान, अगर आपको कुछ सीखना है और कुछ ज्ञान प्राप्त करना चाहते हैं तो कृपा करके सभी लोग सीरियसनेस के साथ और पूरे ध्यान पूर्वक जो हमारे एक्सपर्ट्स पूरे देश से आए हुए हैं उनको सुने, और जिसका इंटरेस्ट नहीं है, जिसको आपस में बात करनी है, वो चुपचाप हॉल से बाहर जा सकता है, उसमें हमें कोई आपत्ति नहीं है। आप लखनऊ घूमना चाहते हैं आप लखनऊ घूमिए, लेकिन बाकी सबको डिस्टर्ब मत करिए जिनको सीरियसली जो है सब्जेक्ट के बारे में सीखना है।
धन्यवाद सर। तो माननीय श्रोतागणों से भी मैं अपना विनम्र निवेदन करूंगा कि जो भी कुछ हम बोल रहे हैं वो एक्सपीरियंस के आधार पर बोल रहे हैं। ये कोई किताबों में लिखी हुई चीजें नहीं है। किताबों में शायद नहीं मिलेंगी, और किताबों में मिलेंगी भी तो कम से कम 20-22 किताबें आपको देखनी पड़ेंगी इधर उधर की, कुछ आउट ऑफ प्रिंट भी हो सकती है। ठीक है, आप खुद समझदार हैं, खुद ध्यान दीजिए। माननीय अध्यक्ष महोदय को भी आपको सचेत करना पड़ा, वार्निंग देना अच्छा रहता है। फुटबॉल में जब डिस्ट्रप्शन हो जाता है ना, तो वो येलो कार्ड वगैरह दिखाया जाता है, तो उसको उसी भावना से, खेल की भावना से इसको लीजिए और सीखने की भावना से लीजिए। तो बेसिकली जो मॉडर्न ग्रिड है उसमें हमारे एक रेजिलियंट सिस्टम की हम बात करते हैं। रेजिलियंट सिस्टम का मतलब है कि सिस्टम में यदि कोई डिस्टर्बेंस हुआ तो वो वापस जल्दी से जल्दी, जितना जल्दी हो सके, अपनी पूर्व स्थिति में आ जाए। ये रेजिलियंट सिस्टम का है। तो इसके लिए हमें क्या करने पड़ेंगे, सफिशिएंट मार्जिन्स बिल्ड करने पड़ेंगे। इसके साथ ही एक आता है कि रेजिलियंट सिस्टम की क्यों जरूरत पड़ती है और क्या हो जाता है। तो डिजास्टर डू हैपन, जैसे आपने देखा होगा साइक्लोन्स आ जाते हैं, एंड दीस साइक्लोन्स create a lot of havoc and lot of damage to all sorts of assets. So electricity system is no exception to that. So when the disaster have there, so disaster preparedness has to be there, and the control centers are already there. डिजास्टर प्रिपेयरनेस के लिए एक सबसे बेसिक चीज है हमारे पास इमरजेंसी रेस्टोरेशन सिस्टम. आई डू नॉट नो हाउ मेनी ऑफ यू नो दैट these emergency restoration system which were earlier imported, say 10 years back, these were imported till 10 years back. Now they are being manufactured in India as per the international standards and they are available. Thing is that they are to be strategically located. For that, one should know what the wind zones are there and what are the cyclone prone area and where and from where these can be easily transported. For that, CA has already done a long-term vision and at strategic locations have been identified and given that so many sets of the ERS has to be kept. So that is the importance of this emergency restoration system. It is not a common thing. It is used only where it is required. Now, recently, one more use of the emergency restoration system is emerging as in the case of the reconducting of the lines. We have to increase sometimes the capacity of the line by the higher size of the conductor or the high temperature low set. That is known as the high performance or new generation conductors. So those new generation conductors, you need not take shutdown, build the line or divert the line parallelly on the emergency restoration system for certain kilometers and then bring back to the normal. So that is being adopted and that is a new innovation which the world has not thought of the emergency restoration system. And anyway, emergency restoration का हाँ सर, कंडक्टर में क्या है, देखिए हमारा नॉर्मली ACSR कंडक्टर है अभी जो स्टैंडर्ड्स हैं, बर्सिंगिस हैं, पैंथर, जेब्रा और ये सब हैं. तो बेसिकली क्या है, अब लोड के बढ़ते बढ़ते या जनरेशन के बढ़ते बढ़ते इसमें जो पावर इवैक्यूएट हो रही है उनका एक सेचुरेशन लेवल आ गया. तो लाइन तो हमारी है, एक रूट जा रहा है, से डबल सर्किट लाइन जा रही है पहले से ही. तो वो कह रहा है कि इस पे और ज्यादा पावर नहीं जा सकती है. तो हम क्या करेंगे, इसमें एक तो तरीका है कि हायर साइज का कंडक्टर लगाएं जो नॉर्मल कंडक्टर है ACSR. उस कंडक्टर को यदि हम लगाएंगे तो हो सकता है कि टावर हमारी सपोर्ट ना कर पाए क्योंकि उस हिसाब से डिजाइन नहीं की गई है, एक पर्टिकुलर साइज को दी हुई है. जो हाई टेम्परेचर लो सैग या न्यू जनरेशन कंडक्टर्स हैं, इनके अंदर में कार्बन, कंपोजिट कार्बन की कोर है, सॉलिड कोर, और उसके ऊपर एल्युमिनियम अलाय है. तो इसका वेट कम हो जाता है, जो एग्जिस्टिंग कंडक्टर है उससे भी कम वेट हो जाता है, रेजिस्टेंस भी इसका कम है और करंट कैरिंग कैपेसिटी 1.5 गुना से 4 गुना तक की भी आती है डिपेंडिंग ऑन रिक्वायरमेंट. टेम्परेचर है इसका जैसे 180 और 250 वैरायटी भी है. तो 250 वैरायटी जाने की शायद जरूरत ना पड़े, 180 डिग्री सेल्सियस वैरायटी से भी काम चल जाएगा. तो वो स्टडी का पार्ट है. उसी के साथ क्या है, हमें सर्किट ब्रेकर की थोड़ी कैपेसिटी बढ़ानी पड़ेगी, नॉर्मल करंट कैरिंग कैपेसिटी बढ़ जाएगी. तो टर्मिनल इक्विपमेंट है तो हम ट्रांसफार्मर की कैपेसिटी भी बढ़ा सकते हैं जिससे वो ज्यादा करंट कैरी कर सके. तो हमें ये रिकंडक्टिंग करने के लिए जनरली शटडाउन लेना पड़ता है सेक्शन वाइज. अब हमारे एक्सपीरियंस इंजीनियर हैं, जैसे ये हैं, सब हैं, सब ने मिलजुल के देखा कि भाई इसमें कहीं कहीं यूटिलिटीज ने कि इसको इमरजेंसी रेस्टोरेशन सिस्टम पे पहले लाइन को बाईपास ले लीजिए और उधर लेके फिर इसको नॉर्मल वाले पे ले आइए. तो इससे टाइम भी सेव हो जाएगा और हमारा शटडाउन की रिक्वायरमेंट्स भी घट जाएगी. तो ऐसे प्रैक्टिकल एक्सपीरियंस है इंडिया में. जिन यूटिलिटीज ने ये किया है उनका हम एक आध का संपर्क बता भी सकते हैं आपके इंजीनियर्स को. तो ये चीज है. दूसरा क्या है, इसको बोस्टिंग ना समझे मेरी तरफ से, ये क्या करके हो कि मेरे पास रिस्पॉन्सिबिलिटी थी मेक इन इंडिया की. हाँ, तो मेक इन इंडिया में ये हुआ, एक यूएस वाली फर्म आई CTC ग्लोबल, ये सारा कोर इसका बाहर से आता था, कंडक्टर्स 4-5 बनाने वाले यहाँ पे हैं, तो वो सारा कोर बाहर से मंगाते थे. तो दे आर इन सर्च ऑफ बिजनेस. तो वो लोग आए यहाँ पे, जो उनके डीलर थे वो लेके आए मेन प्रोप्राइटर को US से, CTC ग्लोबल. तो उसने कहा सर हम कंपनी लगा लें यहाँ. मैं कहा यस यू स्टार्ट टुडे. मैं कहा हैव यू टेकन द लैंड? So the local dealer told, sir, the land has been identified, we have to acquire it. And you won't believe, sir, with constant motivation and persuasion and their willingness and our commitment, they got convinced, and within 2.5 years, the production of the core started. So that's how it's a basically leadership lecture you can take. That is how you convince the who is coming to invest here. They invested, they started manufacturing, and our conductor manufacturing getting benefit out of it. उनकी देखा देखी दूसरे लोगों ने भी कोर बनाना शुरू कर दिया है. तो अगेन द कंपटीशन हैज कम. तो दिस इज हाउ द मेक इन इंडिया कम्स, दिस इज हाउ द कंपटीशन कम्स, एंड दिस इज हाउ यू गेट द बेटर रेट्स. ये एक चीज है. इसी तरह से हमने ट्रांसफॉर्मर्स में किया था. ट्रांसफॉर्मर में वन चाइनीज फर्म इज देयर इन बड़ौदा. So they were disrupting the market and all those things, and our manufacturers were going to close down their shops, say about 8 years back. They came, what to do? We told them that keep patience. Government is doing something. It is where the policy takes place. It is where the role is of sir and the people like that under their guidance. ठीक है. तो मेक इन इंडिया होना है तो उनके पास ऐसी स्थिति है, दे आर नॉट एबल टू मीट द मार्केट डिमांड्स. देयर ऑर्डर बुक्स आर सो फुल. क्रेडिट गोज टू द लॉट ऑफ रिन्यूएबल डेवलपमेंट एंड अदर कैपेसिटी डेवलपमेंट, लोड ग्रोथ, सो मेनी सब स्टेशंस कमिंग, द स्टेट लेवल प्लानिंग, स्टेट लेवल ट्रांसमिशन एडिक्वेसी, स्टेट लेवल जनरेशन एडिक्वेसी, रिसोर्स एडिक्वेसी प्लान जो आपके बनाए गए हैं. सो इट्स बेसिकली द होल इंटीग्रेटेड थिंग. Many things are done in the offices, not only in the field itself. Field personnel have the challenging job, have the tough job, but more stressful job is that of the persons who are sitting behind on the table and under whose signatures the policy decisions are or the design parameters are being set. ये चीज है. And of course, who are the beneficiaries? Beneficiaries are all of us, the whole nation, and ultimately you can say the whole globe is beneficiary because the emissions are getting controlled. So naturally transmission has to be the backbone of the economy, and a robust, stable grid is needed to meet the requirement of reliable power. You see the importance of the strong grid and strong interconnection with the countries. You can say, understand how we are trading the electricity with Bhutan, how we are exchanging the electricity to and fro from Nepal. And also, of course, Bangladesh were also well connected. Some recent disturbances, that's a different issue, that is a government to government issue. But these interconnections helps in building the brotherhood and the international cooperation. So we already have one nation, one grid concept that is operating successfully. Many advantages have been offered by the one grid. Otherwise, there used to be the frequencies which were varying and having large scale fluctuations. And now is the concept of one sun, one world, one grid. This you might have heard several times, but do you understand what is this one sun, one world, and one grid? Because it is said that the sun never sets throughout the globe. When the sun is shining here, at other place it is not shining. So whatsoever the natural benefits of the sun is there, that solar in the form of the solar energy, we utilize, and when we are in excess, we can supply to the others, and vice versa. So that is happening. Energy efficiency is the buzzword. We at the government level have the energy efficiency department known as the Bureau of Energy Efficiency. And in every utility, we have now the concept of environmental sustainability group, ESG. So certain commitments, there are many things under this, that is the PAT, perform, achieve, and trade, transmission availability, transmission losses, and naturally the transmission losses should be in a defined range, not more than 3%, but major cause is in the distribution. So what I told, that the strong transmission system and the better conductor systems and high efficiency conductor systems, now it is time also, gone is the era that earlier we were making the distribution system. I'm appealing to most of the new engineers. Earlier the concept was we were not having that much strong economy, and the finances were a constant. And we were to extend the electricity to the far-flung villages and the rural areas, and particularly for the irrigation needs. So whatsoever the available conductors, whatsoever the available distribution transformers, those were being deployed. But now the time is that build the system. इस शब्द को जो है, इस वाक्य को, फ्रेज को गांठ बांध लीजिए, खासतौर से इलेक्ट्रिकल इंजीनियर. फॉर द फर्स्ट टाइम राइट. For the first time, right means meeting the immediate need as well as meeting the demand of the future. It's a common experience also and documented text by the standard authors also, that if you do reconducting of the distribution system, first you have to dismantle, then lay the another type of the conductor. Your support may not be capable. So better you build it slightly higher capacity, so that in future you need not face any problem. Particularly your utility engineers or counterpart. हाँ कर दें. So वो इशारा कर दीजिए हमें. So what is happening? No one allows a pole in front of his house. No one allows easily a tower or a pole in front of or in the field or wherever whatever is the location. Urban areas particularly are the very dense areas where the right of way problem is going to be more and more severe. Forest is another challenge. So for the forest, we have to devise special means. And what is happening is the ambient temperature, if you see the trend, is rising and rising, and we have to take care, because the assets which are being created today have to last, say, for at least 40 years. So whatever the components we are going to build, going to place in the field, they should bear the harsh conditions of the ambient likely to come in future. Generally 45 degrees Celsius ambient or 40 degrees Celsius maximum temperature is the design parameters. You have to see yourself that which type of the component you are going to use. Maybe 50 degrees Celsius ambient will be the normal in future. So what will be? It has to start from the planning stage. This I have emphasized. Advanced models and softwares. Basically, the era is of computation. So we can build up the models, we can use the softwares, we can use the design and simulation softwares, and we could see the performance on our desktops by sitting in our offices, and that should be reflected in the field. For that, we have to require a review of the existing system. So basically, it is here I am emphasizing the database. Database has to be very firm, very secure, very reliable, so that whatever we are analyzing should give the true results. Proposed and load generation system details are needed to devise the system, and system has to be devised for a long-term basis. As far as when the fault level comes, the fault levels are decided well in advance, because the fault level cannot change or the switchgear cannot change for the extended fault levels too frequently. And when the fault level are rising, we have to, I have got some slides here also, how to take care when the fault level is increasing and our say switchgear is of say 31 kiloampere and the fault level has gone to 40 kiloampere. Now recently we have told EMA and the Bureau of Indian Standard to develop the circuit breaker switchgears at 765 kV for 63 kiloampere. 63 kiloamperes के अभी नहीं है, एक दो मैन्युफैक्चर बनाते हैं, but they have to be more as the system is expanding and paralleling. First of all, what has to be attempted? It has to be done based on the audit and whatever your logbook says. Frequent faults. It means the attention is required at the very first opportunity. When an opportunity comes to take the shutdown, that has to be attempted first. So that comes with the system audit. प्रोटेक्शन ऑडिट भी उसमें होता है, एनर्जी ऑडिट भी होता है, लॉसेज का ऑडिट होता है, बहुत सारे ऑडिट्स हैं. इलेक्ट्रोमैग्नेटिक इंटरफेरेंस का भी ऑडिट होता है. टेक्नोलॉजी धीरे धीरे ऑब्सोलेट भी हो जाती है, but obsolescence or prudence check need to be done. One such example is, I would like to say, the use of insulators, particularly at the EHV and HV levels. A trend came in between that use the polymer insulators, but its use is quite debatable as far as its overall life is concerned, as far as its failure history is concerned. Utilities, on their own experiences, they are now resorting to the well-established porcelain or glass-based insulator, and in case of the porcelain, say 31 mm per kV creepage distance, and from the downside, it can be room temperature vulcanite (RTV) coating that increases the hydrophobicity and gives better performance. What happens? Initially, the polymer can be cheaper, but after 2-3 years, it starts giving problem. When you have to change, the number is large. A farmer will not allow you to enter to his field time and again. And you see the cost and inconvenience of the replacement of those type of the faulty insulators. So quality checks is must, provenness of the technology is must. What suits you to be applied, that knowledge is must. So in this direction, we can have the learning from others. Railways are changing polymer to porcelain. Railways also went ahead with the polymer, but when they saw that it is giving problem, they again change but increase the keepage distance. So that is giving better result. Similarly, in the European world also, who started long back, they are also going to their glass. It is basically LGC. Glass is there and porcelain is for our tropical conditions. We can also use glass equally. This is this. So learning from failures is here, and case specific root cause analysis need to be done. We should take the help of the labs and standard scientists, those who are. We should not get biased. Say one is saying, the OEM or the supplier may give his biased view. It is better. But maybe you are entering into the problem. So that is one aspect of the modernization. So in the name of the modernization itself, we should not go in. We should have our own prudence check and logical decision. At the same time, there is a lot of emphasis is on circular economy. So we have to see the circular economy aspect. Techno-economic considerations suiting to our local needs and local this one. Of course, in UP, there is no, say, ice-prone area, but those who are snow-mounted and those areas, snow-bound areas, there the special type of the steels for the construction towers has to be there. Timely upgradation is a must, otherwise this system will become weak and will lead to the larger problem. Safety requirements, in the name of the hurry and all those things, we should not disobey the laid down rules, and those rules are that the safety first. It should be the buzzword for each and every engineers, those who are in the field or those who are in safety first. बेल्ट भी लगा के चलनी है और हेलमेट भी लगा के जहां जरूरत है चलना है, और जिस तरह की सेफ्टी चाहिए. दूसरा है हॉटलाइन मेंटेनेंस है, उसके लिए स्पेशल ट्रेनिंग होती है, एंड दैट हॉटलाइन मेंटेनेंस हैज इट्स ओन दिस वन. So aging infrastructure is one. Communication requirements, they are the hidden things, and the communication is an integral part of the transmission system. Without the modern communication system, you cannot think of now building an efficient transmission system and operating it. There are measurement needs, and these measurement needs are IEDs are also there, that is the intelligent electronic devices, and all the substations, they are 61850, IEC 61850 compliant, which is reducing lot of wiring, and those IEC 61850 copper wiring and cyber security aspects getting reduced. And with growing system complexities, we have to have in our system the sufficient and efficient SCADA system, SCADA security, and the wide area measurement system, which will be based on the deployment of phasor measurement unit. Recently, in case of the transmission system, earlier the OPGW was of 24 fibers only. But now it is in the guidelines itself, say about a year back, we have changed it to minimum 48. And in case of some of the locations, say in Maharashtra and others, they are going up to 144 fibers also. Similarly, the capacity of the fiber optic terminal equipment. So these are all your part of the transmission system. Your transmission line or transmission system is not only towers, insulators, and the wires. It has many, many things, and it has many, many embedded software controls, which are being operated by very, very responsible persons in a dedicated manner round the clock. So next generation technology for the adoption have to, you study, keep on studying them, and what suits need to be adopted when the time comes. Reason is that we should keep on studying the technologies, what others are using and what we can, at least on the pilot basis. One more important come when we talk of the modernization, that is the site selections. Sometimes what happens, the site is selected and later on a temple or some structure is found there. It's a practical example. So site selection should be very, very careful on scientific basis, and soil and geographical considerations should be seen. Particularly in the hill area, the location of the substation is fixed. But what happens, the approach road is not there. Particularly, I give you the practical example of the Luhri generation facility, which unfortunately the Luhri stage 1 is not coming because of the geological conditions. They were insisting that transmission substation will be here. When we talk to the person, the OEMs and others, stakeholders, they say, sir, the cliff is there. And this type of the cliff is here and transformer is this much. So naturally it cannot go. So generation facility owner says, no, it is the responsibility of the transmission substation developer. They will somehow bring the transformer. So big question. Anyway, I will not extend it much. We did not. I particularly did not allow. Similar thing happened in Sirohi. Kumbhalgarh forest, they were taking, here is eco-sensitive zone, here is some wildlife, and this, whatsoever the small patch was there, that was likely to be notified. The transmission developers or transmission planner says, no, sir, in today's date, it is not notified, but the letter says it is likely to be notified. Maybe they may notify in next 1 month, next day. What will happen? The whole investment will stuck up. The route was diverted. And that सिरोही सब स्टेशन एरिया, ये जीरा जो पैदा होता है ना, उस एरिया में जीरा पैदा होता है, तो किसी तरह से पानी की कमी है. उन्होंने ड्रिंकिंग वाटर और सिंचाई के पानी का कुछ व्यवस्था की थी, बहुत सारे पाइप्स थे. Somehow in a hurry, those people, will not name the people nor the utility, they decided a location of the substation far off, away from this. But that was on that water power network. So such type of the things, one should have a proper coordination, proper consultation and proper confidence in the local workforce also. तो वहां से उसको फिर हटाना पड़ा. ये चीज है, मामला संसद वगैरह में भी उठा, वो दूसरी चीजें हैं. तो such type of the things should not come. It incurs cost, it leads to time overrun, time and cost overrun both, and lot of inconvenience, and the project get delayed. People get, who get paid name? The planners and the transmission executor. Yeah, right. So rocky and desert soils, they are basically of particular interest. What happens that there are type of the earthing system which are defined in IEEE 80 also, and that particular clause is there, that not dependent on the wet soil. That type of the earthing need to be there. What happens when the water is not there, the earthing system will become poor, very poor and high earth resistance. So it lead to the failures in the later run. There are earth enhancing compound which said, which is called as the solid earthing, you can say in common term, and does not require frequent watering or dependency on the soil. So there automatically some chemical compounds are there. They help in this one. Right of way issue and the vegetation management. Vegetation management for the first time. Vegetation management during the operation also, chopping of the branches. So a special type of towers are there. That is the narrow base towers. The monopoles are quite common. At least 3 to 4 manufacturers of monopoles are now there. And if you happen to go to say Noida and this area and some other areas, lot of monopoles are proving their advantages. And in case of the monopole foundations also, a different type of the foundation has been developed which settles within 3 days only. So I can convey to Piyush ji, the whosoever, because from this forum, if I name the company is not good, not desirable, but there are technologies that the foundation which takes in settling long time, within 3 days, it can be settled. And another is the screw type of the foundations also, those are coming. So they are saving the times and doing very fast. As regard to the transformer protection, there are the 2 type of the transformer fire protection have to be there. One is the nitrogen injection fire prevention system, which cools down the transformers in case of very high pressure development and very high temperature development inside. And over and above, the water mist system should be there, because there is no reliability that when the fire takes place and the transformer has to be cooled down, the water would be available, and the nozzles which are there, which generally should not be used or are not in use, they get choked. So water mist based systems are solution, and they require very less water. So this has to be reviewed in our construction standards. One more appeal to my fellow engineers here is that wherever you feel that the construction standards or the regulation are coming in your way and they need to be changed, please do write back to the appropriate authorities. Say it could be CEA, it could be BIS. So BIS, what is doing? Say I am heading as chairman of Electrotechnical Division Council of the Bureau of Indian Standards. So whatsoever electrical related standard you see, there are some 55 committees on different items, conductors difference, insulator difference, capacitor, transformer, this, that, and even the appliances also. So whatsoever the feedback comes, those are discussed in the sectional committee. Sectional committees, after finalization, give to me, I approve, and then it becomes a national standard. So we have many times seen that there were deficiency or say not matching or the contradictory requirement among the different standards. So those can be rectified. It is basically the constant feedback and use mechanism. Conducting security and mock drills is one such thing. At the SLDC level, RLDC level, these mock drills are generally conducted. And also, though of course it is not part of the transmission system, but let me emphasize here the importance of the mock drills, that how the black start will take place. So ये चीज ये की जा रही हैं. Natural and man-made disasters are there. By man-made disaster, you may see that sometimes they damage the tower and the whole line goes down. What we have to follow is, we should first very carefully go through the OEM instructions before commissioning of a particular type of the equipment. System hardware and system software updates are must. Cyber security audit and the help of the CCERT is also necessary. Training needs we cannot ignore. I have to rush slide fast. Technical and at the same time, the psychological training should be part of the young engineers. They should be built up. It is basically should be the exercise of their, you can say, the character build-up, though it may sound a lecture only, but it's very much necessary. आपको घबराना नहीं है कि कोई डिजास्टर हो जाए या कुछ हो जाए, तो उसको टैकल करने का तरीका आना चाहिए, ये मेरा कहना चाहता हूँ. And for ensuring the quality of the product, our bids, our tender specifications should be very, very clear. There should be check and hold points, and shop floor visits should be organized, and regular inspections should be carried out at the workplace. Same type of the precautions and same type of the insurances should be taken for when it is transported. And particularly when it comes to the BES, battery seems to be a simple device, but there are ISO standards. As per this, it has to be transported. Battery is not a simple thing. It has to be transported in specialized vehicles and as per standard methods. Again, let us go to the desktop. That is the system studies and security issues. Condition monitoring techniques, new things are being developed. Spectrometers you must be using. And when we talk of the transmission towers and the steels and the copper bus bars, the percentage of oxygen is basically lifeline for us, but when it comes to the steel, it is poison for the steel. So spectrometer is the instrument. Earlier JICE used to supply, and some more metal power and like that. There are many companies, just remembering these two. So they supply. So we have to these vibration analysis and the seismic consideration, and the wind zones are changing. And for the coastal, of course, not applicable to UP system.
सभा कक्ष में माननीय अपर मुख्य सचिव ऊर्जा महोदय का आगमन हो चुका है. मैं उनका हार्दिक स्वागत एवं अभिनंदन करता हूं. कृपया.
नमस्कार सर, आपकी अनुमति से मैं थोड़ा जारी रखता हूँ. हाँ, मैं एक yes. तो हम सब लोग न्यू जेन हैं, तो न्यू जेन कंडक्टर्स की भी बात करेंगे. न्यू जेन कंडक्टर्स में हमारे आते हैं एल्यूमिनियम 59 है, AL59 का कंडक्टर्स है. अच्छा, एक लास्ट स्लाइड करके और कर देते हैं, ठीक है. तो मेरे पास अभी बस 2-4 सेंटेंस ही कहने के लिए हैं और ये कंक्लूड होने वाला है. हम लोगों को अभी बनाना पड़ेगा राइट ऑफ वे की प्रॉब्लम देखने के लिए मल्टी वोल्टेज एंड मल्टी सर्किट लाइन. हमारा जो OPGW रहेगा, OPGW ऑफ द सफिशिएंट कैपेसिटी विच कुड टेक द कॉमर्शियल एज वेल एज द सिस्टम नीड. Wind velocity measurement instrument installation at typical locations is missing right now. Then there is a concept of the dynamic line rating. Dynamic line rating is basically part of the digitalization. So with the help of the AI, IoT based sensors and this dynamic line rating, we can increase the capacity of the existing lines. Then power electronics interventions में आ जाएंगे हमारे HVDC, FACS devices, filter for power quality. Solid state transformers are in picture now. They are in existence in small capacity, but later on with the development of the power electronics, they will be at the high capacity also. Then digital substations, सबसी केबल्स का मैंने बताया कि हमने एक DPR बनवाने का काम किया है, जिसका काम चल रहा है तेज गति से. उसमें हम क्या कर रहे हैं कि जब सबसी केबल की हमें जरूरत पड़ेगी तो हमारे पास सबसी केबल मैन्युफैक्चर्ड अवस्था में हो, लेकिन हमें यही नहीं पता है कि वो कैसे बनेगा. तो इसके लिए एक DPR बनाई जा रही है कि वो कैसे बनाया जाएगा, किन किन बातों का ध्यान रखना पड़ेगा. और दूसरी बातें क्या होगी, जो हमारे ये L1 और ये इशू हैं, इस पे एक नेशनल बहस की जरूरत है. और एक क्वालिफाइंग रिक्वायरमेंट एक होती है कि 3 साल से आप सिस्टम में एग्जिस्ट होने चाहिए, और ये बनाया तो उसने आज है, 3 साल से कैसे हो जाएगा. तो ये एक चीज है, जिसको के रिलैक्स करना पड़ेगा. कुछ चैलेंजेज हमारे पास हैं. बुशिंग्स की हमारे पास समस्या है, RIP और RIS बुशिंग दोनों की. CRGO हमारे पास नहीं है ट्रांसफॉर्मर की कोर के लिए. कॉपर की भी तंगी है. और फायर फाइटिंग इक्विपमेंट हमें उन्नत किस्म के बनाने पड़ेंगे, और जहां वाटर स्केर्सिटी की लोकेशंस है वहां अर्थिंग और वाटर मिस्ट टाइप के करने पड़ेंगे। दूसरा क्या है, एक चीज और रेगुलेशन में चेंज करना पड़ेगा। दिस इज माय लास्ट सेंटेंस एंड दिस लास्ट इज बेसिकली 400 केवी लाइन से आप डायरेक्ट टैप करके एक छोटा सब स्टेशन बना सकते हैं, से 250 केवीए और लाइक दैट, और 1 MVA, और लोकल एरिया को आप सप्लाई कर सकते हैं। तो ये चीजें व्यवहार में लानी पड़ेंगी। उसके लिए रेगुलेशन में कहीं कहीं चेंज करना पड़ेगा, क्योंकि 400 केवी लाइन की डायरेक्ट टैपिंग जो है एज पर लॉ अभी अलाउड नहीं है हमारे कंट्री में, लेकिन दूसरे कंट्री में है। एक जो चीज आती है बहुत बड़ी कि कंजेस्टेड एरिया में हम ना केबल ले जा सकते हैं ना हाई वोल्टेज लाइन ले जा सकते हैं, तो वहां पे गैस इंसुलेटेड लाइंस का प्रावधान करना पड़ेगा। अनमैन्ड और रिमोटली ऑपरेटेड सब स्टेशन का करना पड़ेगा, और स्मार्ट ग्रिड्स के जितने भी डेवलपमेंट हैं उसके साथ कदम से कदम मिला के चलना पड़ेगा। और दूसरा क्या है कि सबसे बड़ी चीज है, हमें अपने लोगों में खुद विश्वास करना पड़ेगा और हमें अपने पे भरोसा जताना पड़ेगा। और भी बहुत सारी चीजें हैं जो आप मेरे से कभी भी इंटरेक्ट कर सकते हैं, मेरा नंबर भी इधर लिखा ही हुआ है। तो इतने के साथ ही मैं सभी को अपना धन्यवाद देता हूं एंड यस।
धन्यवाद महोदय।